Thank you very much. It's great to be back. I enjoy what you are doing at BCS. You may know that data is my passion. Data security and privacy is the focus of my new book. And there's a 20% discount for the members in your organization. And
wow.
I will share that information with you. The details where you can go into the CRC website and apply the code for the 20% discount. And I will address a couple of the areas from my book today. And then in October, I will present some additional information from the book. So data confidentiality and integrity, I think is very, very important. I think that we forget to talk about integrity, data integrity, in many cases. I think it's becoming more and more important. It's how you can trust the data. Where did the data come from? Is it manipulated, and so on. So on the left-hand side, you can see a little bit about what I have done, and at the bottom, you can see some work that I engaged in different standard bodies. You have on the left-hand side, you have the standard body for financial services in US. At the center, at the bottom, you can see some of the work groups, task forces that I helped out with in the payment card industry. And on the right-hand side, you can see some of my articles from the ISSA journal, I would say technical security journal. And they are, of course, focused on data privacy, data security. And I also have a couple of articles published in the ISACA journal that are more focused on compliance and audit. So this is what we have shared with you about the summary for this session. So this is basically what we are going to cover. At the bottom on the left-hand side, you can see some examples of topics that we will start to go into. Then in the second session in October, I will go a little bit deeper in some of the areas based on what you think are interesting. I hear a lot about zero trust from many people, and maybe I go a little bit deeper into zero trust in the next session. And we start today by introducing zero trust and how I view that very, very important area. And it came up 10 years ago. A friend of mine worked at Forrester Research. His name is John Kindervag. And 10 years ago, he invented zero trust, the concept of zero trust, because he was asking the question, why is security not working? And he started to think about how we should rethink the whole concept. So we'll talk a little bit about that today. On the right-hand side, you can see some of my blogging. This is from the ISACA security group, where you can see I I talked about preserving privacy with new technologies in one of the blogs. So I always think that use cases are important. Technology is good, but you need to put it in a context, a business context. So we know, why are we doing this? How will it help our business? How will it make a better world for data generation, data analytics, data sharing, and data use? So you can see some of the ways I try to define these use cases on the left-hand side, operational systems, and then analytical systems, and in data sharing then, and what does it mean for our applications. So I will come back during my session to a couple of these use cases. Every year we get a report from Verizon. The DBIR came out recently, and it's I think very interesting, because it's a summary of a lot of data globally, data breach data, real data breaches that had some consequences. And Verizon and their partners globally always do a very good study of what happened and what can you do. So we can see that social engineering is still up there, but different type of system intrusions, you can see the definition at the bottom, is spiking up over the last couple of years. And particularly for retail industry, and I'm very engaged in financial industry, as you saw from my work in the standard bodies. And you can see the system intrusion is way up there, and privilege misuse is not too high in represented in breaches. So what are people telling me? What are the problems? And to make this very simple, in many cases I hear issues with trust. People are saying, is this the real user? Can I trust this user? Or is this an attacker? And it's applicable to all access to data and applications and networks. And secondly, I very frequently hear that, where is my data? Is it in cloud? Can I trust the database? Is the cloud leaking my data? What more should I think of where data is stored? We'll talk a lot about that today. And then more and more we have seen that Amazon, Google, Alphabet, Facebook, Meta are selling my data, selling the data that I shared with them. And in many cases, they don't ask if they can share the data, if they can profit from the data. And we know that in many cases, it's a core business model. So we'll talk a little bit about that. What can we do? Because current hosting model is just giving away all my sensitive data to the hosting provider. And I will talk about how that can change over time. On the right-hand side, you can see the red regulations. And we have the European GDPR and state legislation in, for example, California. And they are, of course, addressing data privacy. And they are saying that you should have control over your data. My book is focused on who owns the new oil, meaning that who can control all the sensitive data? So we'll talk a little bit about that. And regulations may not be enough. These companies continue profiting from the sensitive data, my personal data. On the technology side, we can see that zero trust architecture can be very effective when it's implemented. In the two left-hand upper areas, trusting the user and trusting the data for not leaking. And then we'll talk about what can we actually add, what technology can we add to prevent these technology companies from selling my data. So we talk about, for example, Web 3.0 a little bit, and we talk about how is that different from our current Web 2.0 that most of these companies are using as the web infrastructure. This is what Gartner is saying, that Web 3.0 will start to take off about now, and it will give you more control of your data. And how can that be? So on the right-hand side, you can see Web 3 redefines the data structure. So we talk about that. We will talk a little bit about that here. And in some cases, this distributed data model is based on blockchain. So we talk about how that will fit into integrity, data sharing, and distribution of data. So Gartner is showing us that the IT security spending is very different from different industries. So you can see financial services and cloud providers and other technology companies, they spend close to 9%. And if you go to healthcare, retail, manufacturing, for example, they have, as you can see on the left-hand side, a lot of data leakage. They lose a lot of data. And you can see that they are spending around 4% on security. And it's interesting to have a discussion about what is the right number, depending on what industry you are in, what region, and what type of data you are protecting. What is the head count for privacy organization in different companies? So if you look on the scale on the left, you can see that the privacy function goes from maybe one person and a little bit more for smaller companies. Early stage companies, you can see the green. When they grow in size, those companies, you can see that privacy function is very different from the more mature companies. You can see there's an elbow in the middle, where you can see a lot of mid-sized companies. Headcount is typical, and when you have startups, so of course they ramp up the privacy function. So the headcount is a little bit more dominating from compared to the whole size. So you can see some data points on the right-hand side at the top, and in the middle you can see some data point that I find interesting. So this study from the Chief Privacy Officer magazine interviewed 471 respondents across 16 industries, and the largest industry sectors were technology, software, and financial services. More data from this study. You can see that top priorities was different for different maturity, and I like just to show these examples, and you can go to the CPU magazine if you want to dig deeper into this, or ask me if you want to have more material about this. So going back to spending on data protection and privacy is very different for different size companies. So you can see the annual budget on the left-hand scale, and you can see how much they spend. And I think it's important to compare that to data breaches and data leakage that we looked at, and we'll talk a little bit more about that also. But these are kind of benchmark values where you can see, is my company spending enough compared to my size and maturity? And more mature companies, they are spending differently than less mature companies. So you can see that from the statistics on this slide. So what is maturity? We'll talk about maturity during the session here. And the question is, of course, what can I do to enhance maturity? And as in many cases, it comes back to a culture thing. Privacy, data privacy is a culture thing that, of course, need to come from the top in the organization. And zero trust, it's not a software that you can buy. It comes from a culture thing, a different thinking, and we'll talk about that. How it's completely different way to think about trust, I would say. So even if the name zero trust can be a little bit puzzling, I think it's a good reminder that we used to trust and then verify, but the zero trust model is turning that backwards, and they say, no, you should not trust. You should start with a zero trust assumption, and then you can build up by verification and validation a higher level of trust. So it's a completely new way of thinking about privacy and security. So we can see here you need to train your team members so they can be more effective. You need to improve compliance and how you manage compliance. So it's pretty basic things, a handful of pretty basic things you can use to increase your compliance. I'm sorry if I'm coughing a little bit. There's something going on here. This is privacy function headcount by size of organization. So you can see some data points where you can benchmark and see where is my company and how much headcount do I have in privacy. This is a survey that is about 1 year old, and it is from the Infotech Research Group that they published in 2022. You can see the data here where they had different organizations, different industries in different regions represented. And that study looked at IT's top talent. What are the priorities? And they showed that the top 10, you can see on the left-hand side, it is innovation. They care about innovation. They want to have a quick hiring process. They want to have a positive climate. They want to have decisions driven by facts, data-driven decisions, instead of guessing and having other ways to and at the bottom you can see diversity. It's not the top one, but diversity is coming in and start to be more and more important. And I think when we have a more diverse world, more diverse workforce, IT need to have a similar diversity. And I think it's great to work with to see that more and more women and other people that can bring another viewpoint is becoming more and more important. On the right hand side you can see some comments about this. I don't want to spend too much time on this, but it's why are people leaving? We are seeing it in the United States that people are giving up for different reasons. They want to have more flexibility, typically, and of course they want higher compensation. On the right hand side you can also see that the professional development is high up as a reason for leaving their job. The culture is pretty high up, and my reflection here is that now during the COVID pandemic, more people are started to work remote, and they want to have that flexibility, continue to have that more flexible opportunity. And we are seeing here in the United States that people want to, in many cases, move to a better location. They can work remote. They don't need to go into a major city to an office to have a qualified, high-paying work. They can more and more work remotely. So it's high up there. And the work-life balance, you can see there on the right-hand side, is becoming more and more important. Benefits also. And then you have, again, diversity is not that important. So it's an interesting study. Ransomware, when we talk about attacks on data and systems, ransomware is just continuing to increase. And you can see different industries. You have industrial engineering high up there, increasing, and you can see at the bottom here you have healthcare, but we are seeing more and more ransomware attacks on healthcare data. research data, attacks that are producing vaccines, attacks on operational systems that is critical to take care about patients, and even if some of these ransomware gangs, the criminals are saying that we will not hit healthcare, and they find out, yeah, they hit our hospitals, they hit healthcare, which is of course much more devastating, can be much more devastating than just financial loss. So IDC is saying that, not surprisingly, that data is growing. So this is the growth of global data. That's their estimate, and you can see there's a hockey stick effect here, where they are saying that this will just continue to increase. And my thinking is that, okay, if we cannot protect the data we have currently, it will just get worse when we get more and more data, more and more platform, more and more technologies and new technologies I think we have heard it in many cases that, for example, from Bruce Schneier, the security guy here in US, he is repeatedly saying that we are providing more functionality than ways to secure the functionality. So he's basically saying that it's getting worse. We are getting more and more exposed. Are we going to cloud? Yeah, but on-premises systems are also growing at the same pace. So no, we are not moving to cloud. We are typically adding new functionality in cloud, but we still are running our legacy systems, mainframes, and we are increasingly creating a hybrid environment. With hybrid cloud, I mean that you have both legacy systems and cloud systems that you need to manage. You need to manage your data across these environments, and it's hard because these different environments, particularly when you go to multi-cloud, meaning that you have data and applications on more than one cloud system, they're all different. Microsoft, they talk about Active Directory, so it can be easier for a Windows shop to add Microsoft Azure. But you are seeing that developers want to develop on Amazon AWS because there is so much functionality that they like. And then you have data analytics people, machine learning. They want to go to Google Cloud Platform because they have amazing capabilities in analytics and machine learning. So it will spread wider, becoming harder. And you need to really think about, how do I manage across these different environments? How can my security and privacy be coordinated between these different environments? So it's a study from IDC. You can see the link at the bottom. Data and security statistics. So I talked about the blue line from IDC that is showing how data is growing, the global data. And at the top, you can see the red numbers from Federal Trade Commission in United States. They are tracking identity thefts, and it's looking pretty ugly. It's just spiking, going up, up, up. And at the bottom, you can see how much data is protected. And it's getting a little bit better, but we are not protecting data with baseline security. There's a lot of data, growing amount of data that not even is protected by a baseline security. So it's getting worse. We need to rethink. Is phishing important? So on the left-hand side, I think too many people are talking about education and phishing and so, but we are seeing supply chain attacks on software distribution and hardware distribution. So I think we need to think about this as a layered problem. You can educate your people, but only it just requires one mistake, and you get the attacks and malware into your system. So of course, we need to apply a layered approach, because when there's no gate, there's no firewall around our systems. So we need to put the protection in different system layers. We need to protect applications, we need to protect data, and networks are important, but it's not, the perimeter is gone. So you cannot have a gate with a firewall that is providing the security. And most of these attacks are going after the data on the right-hand side. Ransomware are more and more selling your data. They may not any longer encrypt your data and destroy your data, because they're finding out that putting pressure on organizations to pay for not leaking the data is becoming more and more a business model. So they steal your data and hold it for ransom. And on the left-hand side at the bottom, you can see that these growing attack models requires no user interaction. It's part of the supply chain, which is requires a new way of thinking about it, the problem. So on the left-hand side, we used to manage our IT infrastructure, data and different systems. And then we added cloud in the middle. And increasingly during the COVID pandemic and other reasons for more distributed systems, you started to create these red area on the right-hand side, more mobile, where people download and keep sensitive information, and maybe store it in cloud that is not managed by corporate. They may not be aware of that hosting for medical records or other applications that are increasingly being used by the workforce. And they are creating their home office where they download and store data. So at the bottom in the middle, the minimum you can do is to encrypt some data feeds before distributing those to these different cloud environments to the shadow IT environments to mobile. So we spend some time talking about that. What techniques can you use? I mentioned Web 3.0 earlier. We have it on the right-hand side, and on the left-hand side we have the current dominating infrastructure, usually called Web 2.0. So we know that Web 1 had static web information. Then Web 2 started to create collaboration. You can upload data, and it's more dynamic data. And the interesting part about Web 3.0 is you can see the middle layer here called sharding. So data sharding, we have had that since databases came, Oracle, DB2, and they're all using sharding because they are growing. So they need to split up, like DB2 started to split up tables, for example, by row count. So they have different different partitions to handle growth. And if you look at Web 2.0, they do these vendors on the left-hand side. You can see the ones we mentioned before. They are doing data sharding in their environment, so they still have that data. If you go to the right hand, where you see the new data model provided by Web 3.0, data sharding and splitting is not inside one environment, it's across different environments. So you can say that, oh, I want to do sharding across several different cloud providers, and maybe with my own equipment, or also on-prem or home office. So it brings control. You can control your data and who you are sharing. The data is still stored, but you control how data can be shared. You can see that the technology stack on the left-hand side. We have the traditional Facebook and Salesforce and so. On the right-hand side at the top, you can see technology that is providing this storage model. For example, Store.J and IPFS, the global distributed storage system. You can see on the browser side, people are starting to use the Brave browser to enable these functionalities. So it's a big shift, and it's coming. You saw the Gartner hockey stick. Web 3 is taking off. Nothing is happening right now, but in the next few years, the hockey stick kicks in, and it provides more sharing, so sharing capabilities, more distributed capabilities, more fail over resilient. So Amazon, if Amazon is down 7 hours, you will have enough redundancy to not be affected in this Web 3.0 world. And of course, the privacy is, you take back control. On the left-hand side, you can see what we talked about as trust issues: trusting the user, trusting the data for not being leaked, trusting hosting providers, do they sell the data? On the right-hand side, you can see some of the technologies. You can see at the bottom, Web3, blockchain, and at the bottom, you can see data provenance, data quality, data flow control, data lineage, and the ledger thing that can show where data came from and your transaction history. At the top, on the right-hand side, you can see zero trust. And it's, as you can see, it's based on a policy. For example, a policy-based access control. Not just role-based access control, the RBAC. This is a dynamic policy-based access control. Because zero trust is dynamic, it's not a static access control model. It's like ABAC, attribute-based access control. So meaning that you are constantly looking at the user. Where is the user? What is the user doing? Is the user moving inside my network, the lateral movement? And it's based on, you can see in the middle top, a context that you can fine tune to your risk appetite, and it's policy driven, and it can control the privacy. So this is an interesting connection between these different concepts, where zero trust is the top, I would say, cultural shift. It's a rethinking of your trust and privacy for your data. Protection techniques, some are easy to implement, and some are a little bit higher cost for implementation. So you can play with your access control that we talked about. You can introduce masking, dynamic data masking, for example, for operational systems also. You can implement tokenization and granular encryption, and we'll talk more about that. Let's go to use case. Now it's getting interesting. So this is an example where a bank is using differential privacy and k-anonymity and pseudonymization techniques to protect the data before feeding that data into machine learning systems and analytics databases. So at the bottom, you can see data came from Oracle, Microsoft SQL, and other sources. And the ETL loading tool introduced data protection. So added data privacy to the data. So you can actually do secure AI and machine learning before using that data in Databricks and Spark and into your machine learning models. In this example, they used the Amazon SageMaker to work with the machine learning model and get some business value out from it. And I think I like to point out that privacy risk went from 26% down to 8% by applying these techniques. How do you know? Because these tools can measure the privacy risk. And then you can also measure the data quality. So they still had 98% accuracy in their analytical data, machine learning. So they found a perfect balance between almost keeping 100% data quality and reducing the privacy risk from 26% down to 8%. So it's, of course, risk management decision. How much utility do I need to keep in my data, and how much risk appetite do I have? How much privacy risk can I afford in my data to still have it useful? Because it's a trade-off. If you want to use the data, you need to make that trade-off. So what did they do? At the top, they removed identifiers or replaced identifiers. They replaced identifiers. by using tokenization and encryption. Usually, like GDPR is talking about pseudonymization. And then they anonymize data. They use k-anonymity, differential privacy, basically adding noise to some of the attributes in your database. And that's how they reduce the risk of identifying individuals. And for some areas in analytics and I would say test environments, they replace data with synthetic data. So they synthetically produced fake data that gave analytics good data quality, or they derived synthetic data from business data. So they could, in that way, they could reduce the privacy risk. And a lot of data was still, of course, in clear text that didn't pose a privacy risk. So if we look at financial services use cases, so on the left-hand side, let's go back to what we talked about before. We have, on the left-hand side, we have data generation. One example is a private bank use case, and you can see some details here about how they generate the data. Here we have the data analytics that we talked about. So we looked at one example for data analytics and machine learning. And here you can see a couple of more use cases, also in financial services. And at the bottom, you can see the data sharing with the machine learning also, and different use cases for global suspicious activity analysis and so. So we can tie these techniques that we talked about to be applicable for different use cases, which is, of course, very important. Technology needs to be understood in how it can be helping your business. And then we have data use. You had different use cases in wealth management, also in financial services, and moving data to cloud, and modernizing applications for cloud. So more use cases. Here we have Amazon AWS on the right-hand side with S3 data buckets. On the left-hand side is the interesting part. Here they are doing encryption key management in their environment. It could be an on-premises environment that they control, or it could be in a private cloud. So the important part here is that they manage the encryption keys, and they also can encrypt data before it goes to the cloud. But you can see in the middle, they are still sharing the encryption keys with cloud. And not every organization wants to share their encryption keys with the cloud provider. Here we have a concept where we're talking about hold your own key. At the bottom left, you can see the difference. On the previous slide, we talked about bring your key. So you can see the key is going to the cloud, but it's managed on the left. And at the bottom left, you can see the two different concepts. Either you share the encryption key, so you share it with the cloud, or you can hold your own key, meaning that you don't share the encryption key with the cloud provider. You are using all these functions on the right-hand side, AWS Lambda functions, AWS Redshift database, Snowflake, AWS Athena, and so. But at the center, you can see hold your own key protection function. So that protection function is actually protecting the key, so it's not shared with the cloud environment and cloud administrators. So that is for the more paranoid people that don't want to share the key. So what are your choices? On the left-hand side, at the top, you can see two variants of hold your own key. The one we saw here is a protect function. That protect function can be an agent running in Lambda, serverless function in AWS Cloud, for example. And far left, you can see the CASB, Cloud Access Security Broker. For example, you are keeping the key in an encryption gateway that is not sharing the key with the cloud. So data gets encrypted and decrypted, passing through that gateway. And the scale on the left-hand side is showing that client control is, of course, higher when you hold on to your encryption keys. And if you go very low and far to the right, AWS hosted key management is the lowest control level, because as a client, you don't know who can access your encryption keys and who can actually see your clear text data. So of course, that is the lowest control level. And then you can play with different variations. In the middle, you have these bring your own key models that we talked about before. And of course, the key can be stored in an HSM, hardware security module, or the client side could make data encryption before sending it. So you have variations of your security here. So you need to see what is the right choice for my different data and where I'm storing it and my use cases, so I actually can use the data. So we talked about tokenization before. On the left-hand side, you can see tokenization, which is a randomized replacement of data. It's a little bit similar to format preserving encryption. FPE is it's a little bit slower because it's performing 10 rounds of, I would say 8 to 10 rounds of AES, block cipher encryption, to encrypt the value. So it's 10 times, basically 10 times slower than AES. And it's not random. It's, of course, using an encryption key and encryption algorithm. And then you have, in the middle, you have homomorphic encryption, which can be very slow, 1,000 times slower than what we talked about here on the left-hand side. But the use case is basically that you do computing on the encrypted data, so you don't decrypt every time you need to operate on the data. On the right-hand side, we have some examples of what we talked about in the use case from the bank. On the, for example, K anonymity and differential privacy. And then you have in the middle data masking for basically test environments. And also for test environments, on the far right, you can have a static derivation or completely fake synthetic data. And there are different use cases. We talked about a couple of different use cases here. So this is what you can apply for different use cases for data in transit, data in use, and data at rest. So you have a lot of choices here to find the right technique, protection technique, to find, as we talked about before, the right balance between utility of the data and protection of the data privacy. Tokenization. Tokenization can be typically done in a big token vault, like an Oracle database, for example, where you store the value pairs between token and clear text data. Or it can be in a more advanced and modern approach. It can be done in a vault-less tokenization. Are they different? Yeah, latency, performance, and footprint are different between these different models. You can see here why they are different. And collision issues, replication, complexity is very different. You can see at the bottom, you have the worst situation with replication and collisions on the vault-based dynamic, and typically they are dynamic because vault-based, of course, you could pre-generate all possible combinations, but it can be very large. It's a static, big, ugly thing. So this is more and more organizations are digging deeper into what should I use for different use cases. And it's interesting when we talk about tokenization. It can prevent attacks from quantum computers. Why? Because it's based on random values. So no computer will be able to attack that random value because it's random. It's not an algorithm that you can try different keys on. So it's becoming more and more interesting. It's not just for PCI and the payment. It's becoming more and more interesting for PII data and all kind of different attributes where you have a name or a number, and more data need to be protected. More and more data is regulated. So tokenization is actually very viable and also applicable to protect against quantum computers. So we talked about different types of data. So on the left-hand side, you can see if you have a simple data flow like payment card data, it can be very viable to tokenize or use format preserving encryption. If you have PII data at the center here, it's typically a more complex data flow for these. It's not just a simple payment system, and you can use tokenization or format preserving encryption for all that block on the right hand side. If you have unstructured data, you have encrypted files, you have a CAT scan in the medical area, health information. More of that data is, of course, more applicable to just encryption, encrypt the file. Quantum attacks. So you have probably heard that the RSA algorithm that is used in most TLS or using TLS and the old SSL will not be secure. It will be a risk of quantum computers cracking that data. It will take a couple of years because it's still an early stage, as you can see in quantum computer sites. You can see the size on the right hand side. When will it be meaningful for businesses to use quantum computers? It's starting slowly now to become real. And standard organizations, for example, in United States, are standardizing new cryptographic algorithms that can withstand attacks from quantum computers. For example, lattice-based algorithms, which is it's not the RSA algorithm, it's not ECC elliptic curve. I mean, if you look at RSA, it's based on the difficulty to calculate large prime numbers and the product of those. And a faster computer can do it faster. So what can you do? So now we are seeing lattice-based encryption are taking is using a lattice, large multi-dimensional lattice for creating the difficulty. So it's calculating the closest points to between different vectors in this lattice. So it's not based on elliptic curves like ECC. It's not based on prime numbers, and lattice-based algorithms can be used not just for preventing these attacks from quantum computers, but also it can be used for in homomorphic encryption. Very interesting area that is becoming more and more relevant. So you can see the timing here. So it takes time to plan and be ready for these attacks and the capabilities for business usefulness in business. So start planning. This is an example of a roadmap. You may want to address different type of areas on the left-hand side: speed, data ownership, data sharing, quantum attacks, data integrity and manipulation, user attacks, data leakage. You can see the range of attacks that we talked about before. At the bottom, you can basically see these different solutions: quantum processing, smart contracts in blockchain, quantum resilient algorithms, data provenance in the middle at the bottom, zero trust for hybrid cloud, and in the center here, you can see a couple of simple handful steps that you can take to implement zero trust. What can you do? MFA, multi-factor authentication, of course. You should use it for all administrators and for all remote access. Number two, replace VPNs with zero trust. In the next session, we will talk more about the details here, where you use software-defined networks. Number three, encrypt all data, all sensitive data at rest in cloud with customer control keys. We have hold your own key and bring your own key as use cases we talked about before. We position them. And segmentation, of course. Number five, segmentation. The whole zero trust came from simple network segmentation. And John Kindervart at Forrester said, maybe we can make network segmentation more intelligent, make it more dynamic, follow the user across the different systems while inside. So this is an example of what a roadmap could look at. So on the right-hand side at the top, Web3 will take some time before it's becoming practical. Quantum computing will take some time before it's becoming interesting. But in the middle, start to plan for quantum threats, because if you encrypt data with RSA algorithm, then it's sitting there and can be attacked one day. Very interesting areas to plan. Zero trust maturity model. How much zero trust do I have? This is from the American government, the CISA organization, where they are saying that you can implement different aspects of zero trust for identity, for device, for network, for applications, and for data. So these areas are defined at the top. And then you can be at different maturity levels. You can see in the middle here. And here we have some more details about the different stages in the maturity. So you can understand how much automation do I have? Have I applied a layer 7 controls, meaning application level? If you look at the OSI stack, where do I actually apply, and how much automation is added? This is my book that came out a couple of days ago. On the right hand side, you can see the link to the publisher, so you can get the book either from the publisher and get the 20% discount, and I will share the secret code with you, or you can go to Amazon and buy it from Amazon. In the middle, you can see here the table of contents, where you have a couple of sections that we have touched on today. And the book is, of course, about privacy and data security, and who is in control. The book is also talking about getting the balance between privacy, security, and compliance, which is a balance act. And you have different people that are concerned about different things. On the left-hand side, you have liability and risk that for example, the board is concerned about. Then at the left-hand side, at the bottom, some people are looking for opportunities in the data. You have data people, marketing people, and they are maybe more focused on exploring opportunities. And then you have the security people on the right-hand side at the top. They need to create a secure environment and focus. Some of these aspects are customer trust. So you don't want to lose the customer trust. And I think that is becoming more and more important. People will not share the data if they cannot trust how the data is handled. And then you have the CISOs, Chief Information Security Officer, that may be, that in many cases have regulations in the focus of compliance. And at the bottom, you have cost, operational aspects. CISO, Chief Information Security Officers, they are changing. They are more and more maturing closer to the business functions, to business unit leaders, board of directors, and not just technology and security and the CIO realm. And this is some numbers from Gartner where they are showing increased interest in strategic planning instead of just security operations. We talked about these different use cases at the top, these 4 different areas. And this is examples of what platforms, popular platforms for operational systems, for analytical systems, managing cloud, and collaboration systems, and then popular applications on the right-hand side. So now, when I talk about these use cases, you typically see them running on these popular platforms. Alignment to standards. I see organizations are more and more interested in different standards and guidelines. So you can see the areas on the left-hand side for US, financial industry, international standards, and different user groups. And then in the middle, you can see the black and gray, where I see that organizations in United States, Europe, and Asia, they in many cases have different focus. And then you can see the standard and guidance to the left of this importance rating, where you can see different NIST standards, you have PCI, you have GDPR, and so. And on the right-hand side, you can see a little bit comments and examples. So thank you very much. I think I'm running out of time here.
So thank you all. That was a very action, sort of information-packed presentation there with lots to digest, lots to take in there. So thank you for that. That was very useful. So just a quick reminder for everyone, I'm going to be asking questions on behalf of the audience to Ulf. If you can put your questions into the Q&A box. If there's a question that's already there that you like, click on the thumbs up to upvote it. It just makes it easiest for us to pull out the questions that are of interest. Just before we go into the questions, you did mention about a code for your book. If you could possibly, when you get a chance, if you could paste that into the chat, it'll make it a little bit easier for people to then find it, because it was on the slide, but we can't copy and paste off the slide. Anyway, the question I thought I'd start with, which I thought would be quite interesting to explore a little bit further, was just getting your thoughts on how to get the right balance right between the people aspects of security and the technology aspects, because clearly it's not all one or the other, but you need to get a balance that's about right. So what are your suggestions for how to get the balance right between people and technology?
Yeah, I think in many organizations forget to do proper risk management. Mm-hmm. So in so many cases, I hear about vendor selection. We need to select the tool. And then when I ask, okay, what is the driver here? Mm-hmm. Why are you doing that? And how do you want to do it? When you understand what is the driver and how you want to solve the problem, then you can go and buy different technology tools. Yeah. So proper risk management always need to be a starting point, and you need to understand your risk appetite. Yeah. And I think to find the balance, you need to understand your use cases. What is the business trying to achieve? On what data? What are the operational aspects? What is the performance? What level of data utility do I need to? We talked about data utility and the data quality. So when you talk about data management and analytics and machine learning, it's of course critical that you can actually use the protected data.
Yeah.
That you find the balance. We saw the use case from a bank. They said, okay, the data quality is still almost 100%. It's 98% in that example, and the tool could report that the risk was reduced from, was it 26% to 8%. So that organization said, oh, that's our balance. We get 98% data quality, and we can reduce the risk dramatically.
Yeah.
So I think that understanding these balances are important, and then you need to be able to. I think you need to be data driven. You cannot be driven by fear. So you need to be data driven. You need to be able to measure. If you cannot measure, you cannot manage. Yeah. Right? So you need to be able to understand how much progress did I make? How much business utility did I preserve? And you need to show these numbers to executives, because they are always asking, what how did you help me?
Yeah, and I think that's one of the questions I'd sort of got lined up for a little bit later, was this: if there's any research or anything balancing about the cost of putting the controls in place compared with the costs of a breach, because clearly it's a bit like buying insurance for your house. You hope your house doesn't burn down and you never have to use the insurance, but if you didn't have the insurance and your house did burn down, massive cost to you. So similarly, in this context, is there any research to sort of demonstrate the costs of breaches compared to the cost of the security and the benefits there?
I mean, I showed examples of some numbers from different industries. They had certain number of lost records, and we have, for example, Ponemon Institute and others. For example, IBM facilitated a study recently where they calculated the cost of a data breach. So there were numbers like $200 per record. So you can actually, and these numbers are different for payment data and for PII data, health data, and you can actually go to the board and say, we have a liability here of so many million, or maybe $1 billion. So this is a liability that we may not want to live with.
Yeah.
And there are certain things you can do to reduce that risk. And if you, in many cases, you have a good standing if you have a good security posture, if you can show that you took reasonable steps. You can never be 100% secure, but if you can show that you actually did take reasonable actions to secure your data and do follow best practices and do what other organizations in your industry are doing, then that's a pretty good starting point.
Yeah. Yeah, that's good. And so interestingly, so Patrick has popped into the chat that he's suggested there are several reports on data risk cost versus risk management, and also another comment that he thinks the numbers, the impacts are much higher than being mentioned, with comments about the US Department of Homeland Security and various agency reports. So clearly there's some big numbers there. Anyway, to move on to one of the questions that one of the audience put in quite a while ago, has been very patiently waiting there. So in the UK, and I'll try and make this sure you understand the context, we've got a health service app, National Health Service app, that's been capturing a lot of data about patients, and people have got concerns about where the data is actually being stored, who will have access to it. Particularly, there's a view now that there are external companies, particularly some US-based companies, getting UK health service data. And so as users, have we gotten access to the information, where it goes? And how do the general public find out about things like this that in theory are being done on our behalf, but somebody may be doing things maybe in a slightly different way than you would like?
Yeah, I think GDPR is an important step in the right direction. And we know that GDPR is concerned about cross-border data transfer, particularly between Europe and US, United States, but also between different countries in Europe. And we pretty recently had interesting court rulings in France and Ireland, some of them based on the Schrems 2, that basically validated. And when I look at those court rulings, a key question is, do you have separation of duties? Are you separating the encryption keys from your data? Who can control the encryption keys? And of course, what type of data do you store? But also, what is the legal statement that you make about not giving up data or access to the data? So I think it's interesting. I looked at some cases between data was stored in Luxembourg, and the encryption keys were kept in France by the client, and they looked at the context here and said, okay, you can do data sharing because we understand you have a separation of duties. And when you talk about Web 3.0, that technology can actually enforce the separation. That can we talked about the difference between Web 2.0 and Web 3.0, and what type of separation of duties that is added in Web 3.0. So I think that can be an interesting technology approach to enforce privacy, because with GDPR it is basically kind of a soft enforcement, and with newer technology like zero trust, for example, Web 3.0, you can actually, from a technology point of view, enforce this separation that is becoming so important when you look at the GDPR, cross-border data transfer, and the Schrems rulings. So I think it can be very powerful to actually implement these privacy controls.
Yeah.
and enforce ownership of the data.
Yeah, okay. So you mentioned there about encryption, and one of the questions that came in from Edith a little while ago was that if the encryption key is a combination of our own key and the cloud provider's key, should this be a medium control on your graph? So that's going back to the slides you're using.
Yeah, key management can be complicated, right? Key management can be complicated. I tried to net it down to who is controlling the key. And on that slide, we saw a spectrum where the cloud provider actually can see the key, can access the key. And at the other end of the spectrum, you keep your key in an environment that you fully control, or you do the administration, or you put it on premises. So you can decide if you want to hold on to the key. So the key cannot be leaked by a cloud provider, for example. Or if you just give up the control and say, okay, the cloud provider is doing the key management and encryption of my data. And in that case, you have no control of the data confidentiality, yeah. or where the key is shared.
Yeah, okay.
And then you have, if you want to go into the details in the middle part of that slide, you can say, okay, I store the key in a hardware security module, or I manage the key, but I share it with a cloud provider. And it's kind of a sliding scale that you need to consider for different type of data.
Yeah. Okay, so we're just running out of time slightly. So Patrick had posted a few questions, but I'm actually going to do, if you like, a hybrid of what Patrick was asking, and then we'll end with Tabish's question. So first off, Patrick, he's on the ISO TC 68 Financial Services Committee. So they're developing, was it the natural person identifier for financial services? So quick plug for Patrick that they, for Working Group 7, if there's anybody who's an expert out there who's got an interest, I think they're after more people to help out. But the key question you're raising was really about with data proliferation and duplication being the driver for a lot of data growth, and also a big cause of reducing data quality, creating interoperability problems. Why don't we focus more on data quality risk, which could actually significantly reduce the attack surface?
Yeah, I would say the cat is out. The horse is out of the barn, basically. There is so much data stored in different places.
Yeah.
You can, of course, improve where you're going. And I think a solution that can be very effective is to just accept that, yeah, we have data in all kind of different environments, and it's exploding. So what can we do? Use different techniques to protect the data. Use automation to apply data protection techniques in these different environments, and we know how to do it.
Yeah.
And we don't need to re-architecture because it can be like boiling the ocean.
Yeah. So I guess that goes back to the point you were making earlier about risk and thinking very carefully about what are the highest risk areas and maybe being more protective of those areas than other areas. Okay. So anyway, so a final question from Tabish, which aligned with one I got prepared earlier also, which was really both about sort of thinking about advice really for people wanting to get into the sector. So Tabish has raised the question, if I'm starting a new role as an information security analyst, at a company that provides software as a service and other cloud products, how do I go about implementing a safety-aware culture? How do I go about getting the skills and getting into the industry, really?
I think the problem we have now is that we have the technologies and in many cases the budget, but we need to take a culture approach and start from a business perspective.
Yeah.
Understanding what makes sense for the business. And if you can bridge the gap between the business and technology security, then you can be very powerful. Put your technology security role in a business perspective. I think that is help change the culture, because without changing the culture, I think business will always win. If they don't understand the value of security, nothing will happen.
Yeah. Okay, that's good. So thank you for that, Ulf. That's been a really interesting, really fact-filled presentation and discussion. Thank you very much for your time on behalf of all the audience from BCS North London branch and from the Data Management Group. Thank you for your time, much appreciated. And just a quick reminder to all that the recording for this will be going up on YouTube. And I think there were a few problems about getting copies of the link to the book, so we'll make sure that goes out in the follow-up email. So that information is going through. So thank you all for attending, and hope to see you at a future webinar. And thank you all.